Hello students. So today I am going to explain the next property, that is commutative property. So let's see the commutative property for whole numbers, integers and rational numbers. So the first one is whole numbers. So here the first basic operation is addition. Okay, the commutative property is nothing but when you change the orders of the number, so you will get the sum is same. Okay, see here the 2 and 7 are the two whole numbers. So when we add these two numbers, so we get 9. The 2 plus 7 is 9. So now interchange these two numbers. Okay, that is 7 plus 2. Okay, the order is changed now. So the 7 plus 2 we will get also 9. So here the LHS is equal to RHS. So this is the commutative property. So when we interchange the orders of the numbers, we get the sum is same. That is LHS is equal to RHS. So here the generally we can write it as A plus B is equal to B plus A. The sum is same. This is the general form. Okay. So now we can easily say that whole numbers are commutative under addition. Whole numbers are commutative under addition. Okay, this is the general form. So this is the statement we can say whole numbers are commutative under addition. Okay, the next operation is subtraction. So now consider two whole numbers. So one is 3, another one is 5. Here operation is minus. Okay, so we know that commutative property means interchange the numbers. So just orders of numbers are changes. So write first 5 and then next is 3. Okay, the 3 minus 5 we will get minus 2. But 5 minus 3 we will get 2. So that the difference is not same. So when we subtract two whole numbers, the difference is not same. That is minus 2 is not equal to plus 2. So we can say that whole numbers are not commutative under subtraction. We know whole numbers are not commutative under subtraction. Okay, because when we subtract any two whole numbers, the difference is not same. Okay, so that we can say whole numbers are not commutative under subtraction. The next operation is multiplication. Okay, now consider two whole numbers. So one is 3, another one is 2. Okay, so interchange these two numbers. The first we will write 2, the next one is 3. So 3 2s are 6, 2 3s are also 6. The product is same. So that is LHS is equal to RHS. So in generally we can write it as A into B is equal to B into A. So we can say that whole numbers are commutative under multiplication. So whole numbers. So simply I can write it as WN. So W is whole, N is whole numbers or commutative under multiplication. Under multiplication. Okay. The last one is division. So the last operation is division. So consider any two whole numbers. That is first one is 2 divided by 6. Okay. interchange. First write 6, next one is 2. So this can be written as 2 by 6, this is 6 by 2. So 2 ones are 2 threes are, we get 3, this is 2 ones are 2 threes are. Sorry. Okay. So here 1 by 3 is not equal to 3. So that is LHS is not equal to RHS. So it means what? The whole numbers are not commutative under division. Remember that whole numbers are not commutative under division. Okay. The next one is integers. So we know that integers are the set of numbers which includes negative integer, that is negative numbers, 0 and positive numbers. We know that integers. Okay. So now the first operation is addition. Okay. So consider any two integers. The first one is -3, another one is 2. Okay. Here the operation is plus. So now interchange. So 2 operation is same. The second number is -3. So -3 plus 2 we get -1. 2 plus of -3 means plus into minus. So 2 minus 3 is -1. So here LHS is equal to RHS. So when we interchange any two integers, so we get same. The sum is same. So we can say that integers are commutative under addition. Integers are commutative under addition. Okay. So in generally we can write it as A plus B is equal to B plus A. This is general form. So the next operation is subtraction. Okay. So see here. The operation is negative. Okay. So consider any two integers. The first one is 3. So the next one is 4. Okay. Now interchange these two numbers. Write 4 minus 3. Okay. So 3 minus 4 we will get -1. 4 minus 3 we will get 1. So here -1 is not equal to +1. So LHS is not equal to RHS. So we can say that integers are not commutative under subtraction. Remember that integers are not commutative under subtraction. Okay. So the next operation is multiplication. See here. Now consider any two integers. So -4 into 2. Now interchange these two numbers. 2 into -4. -4 into 2 is -8. 2 into -4 is also -8. So here LHS is equal to RHS. So in generally we can write it as A into B is equal to B into A. So when we multiply any two integers and interchange those two integers, the product is always same. So that integers are commutative under multiplication. Integers are commutative under multiplication. The last one is division. Okay. So now consider two integers, that is -2 divided by 4. Another, so interchange now this one. So 4 divided by -2. So this can also be written as -2 divided by 4. 4 divided by -2. Okay, this is the commutative property. So 2 ones are 2 twos are, we get minus 1 by 2. 2 ones are 2 twos are, we get minus 2. Here minus 1 by 2 not equal to minus 2. So that integers are not commutative under division. Remember that integers are not commutative under division. So now the last one is rational numbers. Okay. So now the same property is holds good or not. Now we have to check that. Okay. The first operation is addition. So the first operation is addition. Okay. Now we have to check the commutative property is holds good for rational numbers or not under addition, subtraction, multiplication and division. So the first operation is addition. So here consider two rational numbers. We know that rational numbers are defined by, so those numbers can be represented in P by Q form. Here P and Q are integers and Q not equal to 0. So here the 1 by 2 and minus 3 by 4 are also examples of the rational numbers. So when we add these two numbers, so see here the LCM of 2 and 4 is 4, and now the calculation here I'll done already, here I'll done. So that is 1 by 2 into 4. So see here the 1 by 2 into LCM, that is 2 ones are 2 twos are, we get 2, and that is minus 3 by 4 into 4, the 4 is cancelled out, we get minus 3. So 2 minus 3 is minus 1 by 4, and here also minus 3 plus 2 is also minus 1 by 4. Here LHS is equal to RHS, and in generally we can write it as A plus B is equal to B plus E. So rational numbers are commutative under addition. So the next operation is subtraction. Consider two rational numbers, and here the operation is minus, that is subtraction. So when we subtract 3 by 2 from 1 by 2, we will get minus 1, and similarly when we subtract 1 by 2 from 3 by 2, we will get plus 1. Okay, see here the LCM of 2 and 2 is 2, and 1 minus 3 is minus 2, 3 minus 1 is plus 2, minus 2 by 2 is minus 1, 2 by 2 is 1. So here the LHS is not equal to RHS, so that rational numbers are not commutative under subtraction. Okay, the next one is multiplication. So here consider two rational numbers, that is 7 by 2 and minus 3 by 2. So the operation is product, that is multiplication. So when we multiply these two numbers, so plus into minus minus, 7 3 is 21, 2 2 is 4. And here also interchange these two numbers, minus 3 by 2 into 7 by 2. 7 3 is minus 21, 2 2 is 4. Here LHS is equal to RHS. In generally we can write it as A into B is equal to B into A. So rational numbers are commutative under multiplication. The last one is division. So consider two rational numbers, 1 by 2 and 3 by 2. So interchange these two numbers, 3 by 2 divide 1 by 2. So 1 by 2 here 2 2 cancelled out, here also 2 2 cancelled out, but we get 1 by 3. Okay, and here also 2 2 cancel, we get 3 by 1, that is 3. So 1 by 3 is not equal to 3. So that rational numbers are not commutative under division, because here LHS is not equal to RHS. So that rational numbers are not commutative under division.